Hello, everyone. Welcome to ITS 140. Okay, so today we are going to continue our discussion of the SQL Injection Lab. I'm going to go over some slides today related to this topic. So in particular, like software assurance and SQL injection. So we'll talk a little bit about that. All right, so you should be seeing, I think, my slides. Okay, and on software. Let me just make sure you're seeing the right. All right, so you should be seeing the software assurance slides right now. All right, so let's go over these. So this is basically, as you know, software security. So the topic is securing things for the web. Right, so securing from vulnerabilities. As you have seen, I like to go over this slide at this point in the semester just to kind of show you, these are considered some of the most important software-related issues, software errors, etc. Now, while we're not going to cover all of these, I just want to show you that we've covered some of these. So we looked at buffer overflow. You can see that here. You can see that here. Buffer overflow, we're kind of discussing some things related to PHP. Okay, PHP, oops. PHP. And then over here, we're talking about, we've also, cryptographic things. And then over here, these are the labs: cross-site scripting, SQL injection, CSRF, and OS command injection types of problems. All right, so that's really what we've been discussing this semester, and you can see that these are some of the top most dangerous software errors, okay? And that's why basically we look at specific labs. So this one, I think, if you've already started to work on the SQL injection lab, should be a very fun lab. As you know, currently I've only assigned the first problem. So today we're just going to discuss this in a little bit more detail. What are the elements that we need to understand about SQL injection? Just like before, we learned about shell code and things in memory and the memory layout. Now, the advantage here is that you guys have taken a lot of SQL courses, so you really should have a good understanding of writing SQL queries, for instance. Okay. So I've talked about this quite a bit. So when we talk about software, with software assurance, we're really talking about both security, but also quality and reliability. So, you want to make sure that the code works really well. So you're concerned with the accidental failure of a program as a result of some random, unanticipated input. You want to improve the design of it, and you want to have effective testing. And so that's really the focus when it comes to quality and reliability. Whereas with software security, you're worried about attackers and how they can, try to inject things into your code and try to manipulate it or damage it in some way or another. And so these are the two areas that we've been discussing in software assurance. So defensive programming is a form of defensive design to ensure continued function of software despite unforeseen usage. It requires attention to all aspects of the program execution environment and type of data it processes. It's called secure programming. And basically you assume nothing, and here's the key word here, you check all potential errors. Now, that's why you have that term project, right? In the term project, you are required to look for all the potential errors that might be there, both for, as I said, quality and security, okay? Now, most of the things that I do in the lab are basically focused on security, but I will do some discussions on what's called white box testing, gray box testing, and black box testing. And we're gonna look at how those approaches are really good to detect errors, both for reliability and security. Okay, so the idea is that you kind of have to be a little bit, you know, paranoid, if you will, about checking for potential errors. So a programmer should never assume a particular function call or library will work as advertised. So you have to kind of handle it with your own code. And that, you know, like I said before, dealing with these things with software assurance, as you've seen, it's very simple. You know, the buffer overflow is such an elaborate attack. It's so complicated. But at the end of the day, it was just about measuring the length of an input, right? And so, and the same applies here for the SQL lab now. When we look at web security, it's the same ideas of validation. I think I explained last week, hopefully, that the single quote is very important and very prominent in SQL injections and has to be dealt with. Okay. So really, you know, these are, I just kind of wanted to stress that. I know we've mentioned a lot of these things already. So really, it all comes down to input, handling inputs. Now, what I want to focus on today is the injection attacks in SQL injection. So this is where I wanted to go through this sequence. So the SQL injection attack, I want to give you a more formal definition of it, and then that way you guys can just work on your lab, you know, this week. Also, before I forget, I want to remind you, what are we doing on Thursday? Presenting, right? Please don't forget that you need to do your demos. I need to sit with every, or usually I would, you know, if we were in the classroom, I would sit with every group and we would go over your project. Obviously, we can't do that right now, but we're going to have to do that through Zoom somehow. So you guys are going to have to share your screens and you need to demo. Also, I did get a question from a student, and actually I can answer that question to everyone. So the question is, actually, the solution is very easy. So I got a question from a student that we were working on the term project and we are running into an error when we try to populate the database. So when they were running the SQL query with the script provided, it says procedures select products already exist. And we aren't sure why or which version of the stored procedure needs to be kept. Would you be able, and so what's happening there is that SQL query actually has a statement that's repeated twice. And so basically what you're doing is you create something, and then when you create it again, it tells you that it's already created. So all you have to do is just read through the code carefully, and you should be able to find it, right? You can either comment it out, or just, you can also, so that you're sure of what you're doing, I would recommend just running, you know, run a statement at a time. Run this little piece, understand what happens, then run that little piece, then let, you know, and that way you'll figure it out. But that's basically that error I have seen before, that students miss that one, and it's a simple solution basically. It's just that there's in the query there the same statement is repeated twice. Does that make sense?
Yes, Professor, I have a question. For the demo, what do we have to show, like what we have so far, or like?
Yeah, it's a demo of what you have so far, but basically what I need to see is at this time that you already have a VM, you already have a server, You already downloaded the files. You already loaded the database. You already have a website. And so when you go to you already configured everything. So the website, when you know, the domain and everything, the host files, everything, Apache, so that when you go to the browser and you type in, you know, give your website a name, let's say myshop.com, something, that it loads. And so now that you actually have seen what the website is and that we can navigate through it, because I'm going to show you, okay, I'm going to say, okay, now this is where the inventory storage is. Did you notice that there's an inventory module in the admin page? Now this is where you go. This is the shopping cart. This is the flow. Now, the shopping cart, I gave an explanation of that some time ago, I believe. And I told you guys that the shopping cart is the most buggy part of the process. It'll break because, first of all, you have to enable HTTPS. You have to make a connection to authorize.net. You have to make sure you have the libcurl library, right? And then there might be a few little errors along the way, and then the email doesn't work, right? And there's all of that. So that part, if you're done with that part, you're actually in really good shape. But I'm not necessarily saying that you should be done with it, but you know, keep in mind we have roughly about what, 6-7 weeks left in the semester, and if you're, you know, you should be working already on the checkout process. If you haven't even gotten to the checkout process and you haven't even like started with setting up the website, you know, getting everything set up takes a little while. Also, there are a few things there. You know, PHP MyAdmin, configure the database, navigating through the websites. But really, what I would recommend is that you should be in the checkout process, because otherwise, I mean, I want to stress this project is big, it's complicated. You have to read a lot of code. Now you have to write very little code from scratch. Grant that, but you still need to do a lot of reading and a lot of making sure that everything runs and debugging. Just even though, you know, 85% of the code is ready to go, just those few little bugs here and there make the whole thing on work, you know, that doesn't work. So you have to fix it. Does that make sense?
Yes.
Great. Are there any other questions, guys?
Nope.
All right. Remember, you have to configure also the logins, right? You'll have to create a login for username and password, and you have to do it securely. This lab, the SQL Injection Lab, will, you know, one of the things that we're addressing is SQL injections through the login. So make sure you don't make this mistake in the term project, okay? Because if you do, you know, that would be not good. All right. So it doesn't seem like there's any other questions, but I wanted to remind you that we will spend all of Thursday just on the demos. For those of you that do their demo first and they, you know, everything's great and everything, then you can work on the lab, the SQL Injection Lab, which is it's a long one, but a nice one. I think it's probably, I would say, in my opinion, it's like the best lab in this class. It's really well-made lab, I think. Anyway, so SQL injection, as you know, is an injection attack. And an injection attack is when a user input is concatenated into a SQL string to form a query. But the user input itself contains SQL code. All right, so again, just like the buffer overflow lab, you were injecting shell code, you were injecting no-ops, you were injecting return addresses. Here, what you're injecting is SQL, and what you need to know is where to inject it. So that helps you to determine, okay, do I need a single quote? Do I need this or that? And so on. Okay. All right, so let's keep going. So for example, suppose we had a text box, and the text box is called text box 1. Right, so we have this text box 1 over here, which a user enters a customer's last name to search for. And the text from the text box is concatenated into a SQL select query, right? So we would have, don't worry about this language, it's just some, excuse me, some language. What matters is that the SQL query, excuse me, is correct. So here we have a new SQL command. And the command is select all from table 1, where last name like, and notice the single quote there. Everything, the string is in double quotes, but we're going to concatenate that with a text box, right? Text box dot text. And then we have another concatenation over here, and then, you know, some parameter. So, and then the single quote that the program is expecting, because you open a single quote here, it's expecting a closing single quote. So the problem is that if you don't validate this in an appropriate way, you know, you're opening a window for an attacker to inject SQL code or do a SQL injection there. So that's really the goal of the lab. And really that's, I mean, this lab is not very complex. The idea is just that. And then we just have to figure out the inputs. Right? So if a user enters in something like Smith, right, in the text box, then we execute the SQL query, select all from table 1 where last name like Smith. Okay, you can see that there. However, if the user enters the string, notice here what's different. Enters the string Smith, single quote to close the original, because remember, we look at the slides, remember here, they're going to enter Smith in text box 1, single quote. This single quote closes that single quote. And then after this, they can have whatever shell SQL injection they want. So for instance, you can see here, there are actually 2 SQL statements in here. This one is completed with the, and then with the semicolon, and now notice what this one is doing here. Drop table, table 1. Obviously, that requires you to have permissions to drop tables. That requires you to know the name of a table and all of that. But, you know, so that may not work if you're good with the principle of least privilege. So what does the principle of least privilege tell us? It tells us that, you know, if you have a if you have a website that uses an account that does not need to delete ever, then do not use an account that has delete powers, right? You should only have a read-write type of an account. So no one will be able to drop your tables based on the principle of least privilege. But if you were not careful with that, you know, then you have a problem. Now, if you notice, the other element of this is that there's another semicolon over here, and you need to provide these these 2 dashes or dash, they provide a comment. So they allow you to comment out everything else. Why do you need to comment out everything else? Well, if we look back over here, we're saying now, you know, Smith, single quote, semicolon, drop table 1. And then you're saying, oh, by the way, dash, dash. So what that means is, remember that this ends here, right? But you still have some SQL code that's in the program itself. So by doing dash dash here, what you're basically doing is you're rendering all of this as non-existent. It's like you got rid of it, you know, And so now you've succeeded in what you wanted to do. Okay, you're concatenating that string, so it'll just comment it out. The double quotes stay to close the string, but these are basically a comment. So they're commented out. So it is like literally like they don't exist. Okay. So that's really the idea there with the comments, and you will use it as you start to do the SQL injections. You know, one thing I mean, if I gave you the SQL injections for this lab, it wouldn't, you know, then what would you do, right? You pretty much just follow a tutorial, but that's the only thing I'm not giving you in this lab is the SQL injections. If you have questions, though, I can help you, but otherwise, you know, I want you guys to figure them out. And here you can see the query as it comes out. So select all from table 1 where last name like Smith, semicolon, the next one, semicolon, and this is a comment. This is comment. Okay. Are there any questions about any of that?
Not right now.
All right, good.
Yeah, I don't have any questions either.
All right, so SQL Injection Attack, the -- prevents the rest of the original query from executing, which would cause a syntax error, right? And the attacker obviously does not want the program to crash. The attacker wants their SQL injection to run. As I said, when you guys do your demos at the end of the semester, and you've created your logins, these very things that we're doing in this lab and your username and password, I will ask you, okay, type this, and there should be no failure. It should be validated properly, okay? And allows the user, in this case the hacker, let's say, to safely insert additional SQL statements into the original query. Whether this is successful depends on the knowledge the hacker has of the data design. So remember, also again, the same principle as before, right? With the buffer overflow lab. It's a disgruntled employee. They left the company, but they were a programmer or they stole the code. They can read the code. They just can't write it or rewrite it. But they know the inputs, and what they're looking for is vulnerabilities based on their knowledge. That's why also both in the project and in this lab, you have access to the var ww where you have the files and you can read through them. And that's how you're going to figure out how to do the attacks. Or how lucky, there's also, they could get lucky, but guessing table names, but that's much more difficult. And also depends very importantly on the permissions that have been granted to the client user, right? So remember the account. And I'll talk, I have something in the slides about this as well. For instance, if the client user did not have any delete privileges, the above injection attack would fail. However, they may still be able to formulate a select query that gave them access to other customers' information. So sometimes, you know, they may not need to delete. They can just, you know, like you're doing in your lab, you're just increasing the salary of some employee, or maybe inserting a new ghost on the payroll, or maybe just looking at information, right? And then, you know, like ransomware, right? So they look at some information and then they said, hey, here's the information. I looked at it, pay a ransom, or I release this, you know, that kind of thing. As always, I would remind you, never do this to any organization, as that's highly illegal. Okay. So validating input. So obviously the solution, you know, I think I've stressed this many times in this class. If you can summarize 450 in 2 words, is input validation. It is necessary to ensure that data conform with any assumptions made about the data before its subsequent use. Input data should be compared against what is wanted. Okay. An alternative is to compare the input data with known dangerous values. So you can have those two approaches of having lists of characters, but in particular in the case of SQL injections, we know that a single quote in there is problematic. Now you might say, but what if someone's name is like O'Donnell or Orion or something like that? So that's certainly an issue, right? That has to be considered. But single quotes should basically be escaped at least. So what's going to happen there is that they can type O'Neill or whatever, and the single quote goes into the database, but it gets escaped. So by escaping it, it means that the MySQL or the whatever SQL server that is running in the background, whenever it sees that single quote, it will not interpret it as a code character. It will interpret it as a data character. Okay. Also, there's prepared statements, which is one of the main very important defenses that we're going to talk about today. And it's actually in your lab as well. You have to implement it as a defense for it. And then, properly develop. That's why you want to have properly developed stored procedures with good input validation, stored prepared statements, etc., that give you a little bit more coverage. So that's why I strongly recommend, as you're doing the SQL query for your project, actually don't just run the whole script. Instead, read it carefully, right? I know you guys do a lot of stored procedures in your other database classes, which is great. So just read through it, run one by one. And, a lot of that code, as I said, is pretty good code. It's not like it's badly written. It's really well written. It's just that it's got a few bugs, some intentional, some, just unfinished things. And if I told you where the errors are, then you're not going to do all the input validation or testing. So that's why I'm not letting you know where they are. Instead, I'm just asking you to test as much as possible in a randomized way, so that you get as much coverage as possible. By only accepting known safe data, the program is more likely to remain secure. This is why drop-downs are always preferred. So a drop-down is always preferred because of that, because it's always, only accepting known safe data. Whenever you have a text box, remember a text box, a user can type whatever they want on a text box. And, it's very critical that you get those right, because you can really compromise your site. Okay. We will see currently, as I said, we're focusing on databases, but you will see that this also applies to JavaScript as well. So alternated encodings, that's another issue to, whenever you use MySQL, you're allowed to kind of set the type of encoding and characters that you're going to use. And that's usually a big deal in a website, so that you can accept, ASCII characters or Unicode, which are for, foreign languages, for instance. All right. So basically what I will say about this, usually you have to decide what type of encoding you're going to allow. And that just means that it's going to allow more characters. So attackers can sometimes know special ways of doing things in, let's say, ASCII versus Unicode. But the great thing about that is that PHP does provide some built-in functions. One of them is something called MySQL Real Escape String. And basically what that does is again, it escapes characters. And you can actually specify to use a version for Unicode or ASCII, UTF-8, and that allows you to, basically the function itself will kind of block out some characters. In this lab, we can see actually one thing that we can do in the code is we can, whenever we run a function like MySQL Real Escape String, we can take that input before running it through MySQL Real Escape String, writing it to a text file. Then we run it through MySQL real escape string and get that output and also write it to a file. And you can actually see the behavior of the functions and how they are doing things. But basically what they're doing is they are escaping characters. So other forms of validation, here in a high level language, we don't really have to worry so much about, you know, overflowing issues, right? That's not a concern here, like buffer overflows. But at the same time, you do want to validate inputs for the size, right? So an appropriate value. So if somebody's going to buy an item, they're probably not going to buy 1 billion of them, right? So range checking is important. Now, input fuzzing, that's just a term. We're not really going to do that much in the class, but it basically relates to software testing. So when we start looking at the basic ways of software testing, you know, you will see that testing all those text boxes by typing inputs in there, it's going to be a lot of work. Again, it's nothing complicated, right? Absolutely nothing complicated about it. It's just work to type A1A, you know, a whole bunch of different characters and to see what happens. So input fuzzing is just a way to automate that process. So some people have developed techniques that allow you to just, with an algorithm, you guys could easily do it with Python. I would actually give bonus points if somebody does that. And you can do the testing of your different website, you know, your different website by just generating random strings and trying to insert them into the web page and then getting the actual output. Okay. All right, and that's basically what I wanted to say about SQL injections in this. I have several slides today, so I really wanted to just cover that from that slide, kind of a formal, oops, kind of a formal presentation. So now I'm going to move on to, so I'm going to close that one. Oh, wait. Yeah, this one. So I'm going to close this one. And I'm going to open the other set of slides, which is a little bit more specific to SQL injection. And I need to share this. All right, so you should now be seeing the slides. All right, and I'm going to, okay, I think that's, so you should now be seeing the slides, software security. So again, you know, the topic that we're discussing is in code injections. Code injections. So let's, you know, describe it a little bit. So the goal is to trick a program into executing an attacker's code by clever input construction that mixes code and data. And that's the classic example of a SQL injection, right? You're mixing up, because when you write a query, if you do a badly written query, I should say, you're mixing code and data, and you don't want to do that. You actually want to separate those channels of what is code and what is data in a good way. Mixed code and data channels have special characters that trigger a context change between what is data and code interpretation. For instance, here, the perfect or classic example of that is the single quote in SQL. This one triggers that context change. So what the goal of the attacker is, or what they want to do, is to inject these meta characters through some clever encoding or manipulation. So supply data is interpreted as code. And that's, this is, I like this slide because it's a really good formal definition of the code injection, right? And what we've been doing all semester. All semester we've been doing code injections, and then the solution, as we've discussed, is some type of input validation and the principle of least privilege. All right, so here this is an example as you had in the exam, right? So basic example by command separation. This is an OS on the OS operating system, assuming like a Linux environment. You have some kind of a shell script, right? You can see that one over here. And the shell basically takes in an input, right? And then you do an ls on the input. And that, your little script runs that. And then also you have some file in the file system. But now when you run example on the command line, you run the executable, notice this. The user provided that input. And if you notice, what they're doing is completing your statement so that you have something here, show everything, but then they put a semicolon to say, oh, by the way, here's another command. And the other command does a chmod, right? And it changes permissions for all the files to read permission for other, okay? And that's a parameter that was not there. If you look, you had read, write, execute, no read over there, okay? So inside the program, the eval statement becomes equivalent to, ls dot semicolon chmod or asterisk. So permissions for the file confidential after the exploit. As you can see here now, you've got the little R there, and the confidential file can now be read. Any statement after the the semicolon will also be executed because this is a command separator. Remember that these are referred to as metadata. Okay, metadata. Now let's look at yet another attack again. Now we're getting more. If you look carefully over here, now you can see this is web. And this is actually your PHP. Right, so it's PHP code, as you will have in this week's lab, and also in all the labs really that we have left in the semester, and really also the term project that you're working on and demoing this Thursday. So here, other attack, enable attacker to execute arbitrary code on the server now. Imagine that. So that's actually, PHP can in fact run commands from PHP on the terminal. So you have to be careful about that, because that would be the worst kind of thing that you want to do, taking an input from a text box and using that input to run something on the command line. Right, that's very similar to the buffer overflow attacks where they were trying to get a shell, right? So you should see that connection there. So again, here the principle of least privilege is extremely important, which if you remember, the principle of least privilege, we also addressed in buffer overflow lab, right? And we were addressing it to get around it. The attacker had to exploit the set UID mechanism. All right, so here we have an example of code injection based on eval in PHP. We assume, for instance, that we have a server-side calculator or some program. The site is site.com and then calc.php. Okay, calc.php takes an input, that is passed via a get array, right? So the get array gets that parameter x. That parameter gets assigned to in, And then if you notice in now, remember that in PHP, the dots are concatenation characters. And so now you're basically taking this, whatever's in, and you're putting it into the context of an eval function, right? That will try to evaluate that parameter. So it is up to now to the attacker to say, huh, okay, I look at this PHP code over here. Ah, I know what I can do. And so what they can do now is the attack, if you look, they'll take the same URL, site.com calc. They know they're using a get array, right? The fact that you're using a get array tells you, oh, I can use this and now just provide my string, my attack, whatever it is. So in this case, they'll do the same thing as always. They complement the original one to make sure that it's done. Then they put in the semicolon, or sorry, not the semicolon. Oh yeah, the semicolon. The semicolon character as a separator, and then notice this one. The eval function, remember that the eval function is in the, so this is a PHP page, and then you have an eval function. And the eval function is going to try to figure out what that is. When it sees system in there, it's going to basically assume that it's almost like if this is a PHP file and I have all my commands like echo, include and whatever, and here I have a system. And what that means, and that is very dangerous, is that you would be calling the terminal, right? The system terminal. And so now notice what it's going to try to do in the terminal command. If the attacker tries to plug this. What is that? What does that do? In the context of a terminal?
Remove any file.
Yeah, exactly. It's remove all the files, right? So it's going to try to basically delete. It's going to try to delete the files. You see that? And again, the attacker via the website tried to do take over the terminal of the server. Notice that nowhere here did you ever intend to kind of talk to the terminal, right? That wasn't really your intention at all. Your intention was to take an input, concatenate it with some parameters, right? But the attacker was pretty clever, put in commands in there, and now it's able to run something on the terminal. Even if they can't really delete because of the principle of least privilege, they might be able to do other things. So that's why studying the code will allow them to determine what damage can be done. Does that make sense, guys?
Yeah.
All right, great. All right, excellent. So this was an example of, we're not going to do a specific lab about this. However, watch out for this in your project. Okay, as I said, I'm not saying either way if I have hidden something like this in your project, but think about it. That would imply that there's some text box, and that text box has something like this or similar. And if you're not careful and you enter something like this, you could end up maybe not removing, but even if it's just an LS, right? Even if it's just an LS, it's not something that should have happened, right? Remember, it's not always about error, or it's not always about like attack or anything. Sometimes it's just unexpected behavior. Unexpected behavior is not what you want. All right. So anyway, that's an example of PHP type of an injection. So defending against code injections, you know, input cleansing and validation. Model the expected input. Discard what doesn't fit, e.g. the meta characters. Right? Keep track of which data has been cleansed. Keep track of all sources of inputs or cleanse as the input is received. Usually what you will see in the project also is that a lot of this it does not need to be done on the server. And in fact, it should not be done on the server, right? You don't want any injection attack to get close to the server. Instead, you use what? What do you use to validate the data on the client side? What do you use to validate the data on the client side? You don't know, really? Okay.
Is it like the same thing, like the format strings?
Not formats. Well, format strings is more of a specific thing of C, but we're in the web development, right? What language, maybe I should have said, would you use to validate inputs on the client side?
The JavaScript.
JavaScript, very good. Thank you. Exactly. So JavaScript is what you would use, right, to do all the validations. Again, in your term project, as you hopefully are reading through it, you have seen that there's a lot of validation, but not everything is validated. You have to create the login page. You're creating it from scratch. You have to also you will have to create a module. I think I mentioned this before. That module is going to be something that you write from scratch, and it can be something like a newsletter or something where people sign in. The requirement is that it should have some inputs, text boxes, and you write that data to the database, and then when you press a button, data from the database gets read and displayed there. So you can, beyond that, you can do whatever. My only concern is that you have inputs that need to be validated, and then I need to see, and then you also need to read the data. All right, so definitely you want to cleanse the data and validate it, you know, input validation. You're going to also do, you can also do like type and range verification, typecasting, right? You know, is it a string? Is it an integer? Is it the appropriate cast or type? And then separating code from data. So that's another one that's really important. You know, basically, is there a way for you to transmit, receive, and manipulate data using different channels than for code, so that you never suffer the problem of mixing code with data and then having a meta character like a single quote in SQL change the context. Okay, but that is actually achieved through the prepared statement, and that's why we're going to look at that one as a good example of how to do just that. All right. The intuitive approach, block or escape all meta characters. But what are they? Well, that is going to depend on what you're doing. You know, that's why, you know, in this class we've covered C, JavaScript, SQL, PHP, you know, the OS. So you've seen examples of all these different contexts. And so you, just like the attacker needs to know how to inject code, you need to know how to defend against that type of code. Right. here we have, for instance, an example of more robust cleansing. You create basically a list of values, and this is usually referred to as, you know, whitelisting or blacklisting. So you're just going to have list of characters that you can use, you know, to define, okay, you know, these are the characters, the only characters should be used, or the characters that should not be used. So you can try both approaches. It depends on your approach. Okay. And then all of this I've said, so, you know, dealing with all these things, we've talked about that. This is an example of the cleverness. I would describe this slide as an example of the cleverness of attackers. So here you can see, for instance, if combinations of characters can produce meta characters, you may need to do several passes. So for example, if A and B are legal, if separated from each other, but A and B is considered a meta character, so bad, then the character D if the character D is not allowed, then your filter, you know, what an attacker could do is they would do ADB, have your filter out D, but the filter then produces the meta character AB, and the meta character AB is also not allowed. And so this example, as I said, is just an example of how clever attackers can be. At the end of the day, all you're doing is manipulating strings. If you think about it, you know, MySQL real escape string, that function, or any other function, they're escaping functions, right? They're, you know, you have a single quote, they put a dash, add a slash, and there's a function called add slashes, basically, that adds, you know, these forward slash, backslash, to kind of comment out that symbol. But an attacker, what we might have is that you have that D and AB are not allowed, right? And you have a filter with a list of these characters. I have D and AB. They are not allowed. If I see them, get rid of them. But then ADB, right? That one is allowed. I mean, it's not in the list, right? So what an attacker, and then you have filters that just get rid of the characters. So what this is saying is, okay, if they enter D, it goes away. If they enter AB, it goes away. If they enter ADB, D is here, and so the attacker or the filter gets rid of that one and leaves AB. But if you think about it, AB is also a unaccepted character. So there's a lot of tricks like this, a lot of playing with the characters. So that's why this is saying, if combinations of characters can produce meta characters, you know, that is more than one character, then you may need to do several passes. So you would have to, after this filter, you would have to check the output as well to make sure that you don't end up with another character. That's what that's saying. All right. Does that make sense, guys? Are there any questions about that?
Nope.
Sounds like it was clear. All right, good. All right, so now we are back again to SQL. So I've said this so many times, but now, you know, formally with the slides, we're going to go over it. So SQL uses single and double quotes. Okay, to switch between data and code, and then semicolons separate SQL statements. The example of this, you know, update users, notice it starts with double quote, set preference color, notice the single quotes for the data, where UID, notice the single quotes, semicolon for separating statements, and then ending double quote. Those are all the meta characters the change context, as it's called, from data to code. Switch between data and code. Right, so this command could be sent from a web front end to a database engine. And this is, the problem is these parameters, right? If these parameters are coming in from user control inputs and they're not properly validated, you might end up with a problem. This command could be, the database engine then would interpret the command. So dynamically, you get those by having inputs, variables, basically. So web applications dynamically generate the necessary database commands by manipulating strings. An example here is, so this is an example of what not to do. Update users, set preference color to input color, and that's just coming from some user provided input where UID is authenticated user. The value here, where the value input color would be originating from the client web browser through the web server, and where the value authorized user would have been stored on the server as verified through some authentication scheme, and there's a session for it and everything. Forms, here it refers to HTML forms, right? HTML forms in client browsers return values to the web server through either, as you know, the post or get request. Right? You've seen that in the action field of the form in HTML that you can specify the post and get request. Later on, as we do other labs related to this, we will look more specifically at get and post. The get results in a URL with a $sign. So for instance, example script, question mark, and then the variable here, color equal red, okay, which is the, the one that we have over here, which goes here, and that's the problem. The value of input color is set to red in the script. Get URLs are convenient to hack, but there isn't any significant difference in the security of either get or post methods, because the data comes from the client web browser regardless and is under the control of the remote attacker. So regardless of get or post, the injected code is still going to reach the server. So don't just think, oh no, I'm using post. So that input is still going to make it to the server if it's not properly input validated. So the SQL table, as you guys are experts in SQL. So the tables are used to store information, as you know, in fields, which are the columns, in relation to a key such as UID. So imagine here now you have a table of users, which you have one in your lab, as you know, right? You had that table, very similar in your lab. And you have, preference color, UID, the privilege, which would be normal or administrator, right? A primary key, and so on. Right? So there's basically, usually when you're attacking SQL, you're targeting some type of a table. That's your goal, right? It's your goal to get to that one. So a malicious SQL query then, what if we could make the web server generate a query like this one, right? So now, we want to say update users, set the preference color to red, set the privilege to administrator, where UID is Joe. So what's the problem here? What are we doing that could be bad in this one? Look at this one here. And then now, what if we could make the web server generate a query like this. What's the problem with this one? You guys think?
You're giving someone
Joe, the user ID is Joe, and Joe's a common name.
So Joe is the intended user that, so initially, remember initially it was authenticated user. But you are gonna try to change that with your code injection to be something else. In this particular case, Joe.
Are you trying to give Joe administrator privileges?
Exactly, that's what you're trying to do. You're trying to change the code so that you could give Joe administrative privileges. Exactly right. Exactly. You see, that's the goal, right? And so now what you have to figure out is, you know the structure of the tables, you know the structure of the database, you know the vulnerabilities, you know what you want to do. So all that remains is you want to craft the code injection, or in this case, the SQL injection. So the question is, can we engineer a value for color where it was red or blue before, given to the web browser so that it generates this query? That's what you're gonna try to do as an attacker, okay? You're gonna try to do that. Make sense?
Yes.
Great. And notice here how code and data are mixed in the same channel, right? So you're basically just using single quotes and double quotes there, and semicolons and commas, etc., to basically try to change this query. So you got to look at other approaches. So one of the best ones is to use an interface that provides separate channels for data and code. And the classic example of this is the prepared statement, okay? Which you will see in your lab. The prepared statement will allow you to do that. So we will see that in a few minutes, a couple of minutes. So adding another SQL query, let's say Joe wants to run a completely different query like delete from users. How could you do that? So how can the value of color be engineered? So here probably we would close one and then do the delete from users, semicolon, dash, dash, and then maybe put something in here, you know, whatever, like that. And the single quote, right? All right, so that is the sort of the approach that we want to take. Okay. Another example is through HTTP. So in the previous example, we assumed that we were taking in a value, input color, probably, you know, as part of the HTML, etc. Here, we could also just pass it through the URL itself. So a malicious URL. Right, send the data via the URL. We will see a lot of these examples when we look at the JavaScript problems. Now, everything is pretty much the same as before when we do this attack, except that the browser interprets certain characters in a funny way. So for instance, the URLs do not like spaces. They also don't like certain characters like this one and that one, right? And a few other ones. So if you need those characters to do your attack and you're passing everything via the URL, then you're going to have to do what is called URL encoding, okay? So here, for instance, we want to do, you know, this attack. Example.com script color, and then here red, single quote, but now we need to provide the semicolon. So this is where the semicolon would go. Unfortunately, the semicolon is not allowed here in this context of the URL, but we have a workaround, which is basically to use something called URL encoding. So with URL encoding, %3b will be semicolon. You probably sometimes, maybe you saw this when you were doing like Word documents and you kind of saved them from a website down, you downloaded it, and then you notice that all the spaces had been replaced with like percentage something. I don't know if you've ever seen that, but that's a situation where you might have come across URL encoding. Maybe you didn't know what was going on, but that's really what it was, is that, you know, the characters were converted to their equivalent because they were being stored in some kind of a web context. All right, and so that's pretty much that as well. We will see, again, more examples of URL encoding as well. All right, so SQL. So what about accounts? And again, the principle. So there's a principle of the least privilege. Can't remember how to spell that. So the principle of least privilege, you know, couldn't the database have a separate account for Joe with only the privileges he needs, e.g. not delete privilege? In theory, yes, right? But in practice, the management of such accounts and privileges and connecting to the database with the correct IDs adds significant complexity. Well, you know, I don't need to sell this too much because I could say to you, okay, do your project right now and create an account for every single user that's going to be logged in. Well, you would tell me that's a lot of work, right? Instead, what you'll have to do for the term project is I would recommend that you create one account for customer, one account for employee, and one account, let's say, for high-level administrator. So at least those 3 accounts would be, at least 2 of them, but you know, 3 would be like perfect. Because in your project, it's an e-commerce site, so you're going to have customers that log in and buy products, but they should not be deleting things, right? And in particular, if one of them did a SQL injection, you don't want that. You also will have the inventory part of the website, which is really a separate module, and that one can have an account that's employee. The employees have, you know, write permission, you know, they can change quantities in the database, etc. And then you can have an administrator if you want that would have overall all permissions, including delete, I guess. So, but that's up to you. Does that make sense, guys? So certainly considering accounts is important here as a defense for these types of code injections. Questions? Okay, I will take that as a no.
Okay, I'm sorry. So in other words, we would have to create like groups instead of like users, right? So that you can add those particular users to those groups, so that those that particular group has like privileges to delete or to write, right?
Well, what this is saying is that you don't have to create at that fine grain level, you know, accounts. You can just have like 3 accounts. One account that, so whenever the user is logged in, you're going to be making connections to the database with an account that only has read permissions, write permission maybe, but no delete permission. When you have somebody in the inventory management, these are the people that fulfill the orders. Maybe they could have higher privileges because, you know, there's only few and they work for your company. It's the way that the database is going to be tied to an account. And so you can specify the permissions of the account, so that the principle of least privilege says, even if somebody used a text box and inserted a delete, it wouldn't work. Does that make sense?
So in other words, like the account would be kind of like a group in like Active Directory, kind of like, right? Because like if you need, like, let's say a customer wants to be added to Amazon or things like that, that account would hold all the clients, right?
The account relates to the database connection. So when you do the
Oh.
when you do the database connection, it's not necessarily that you're taking accounts and putting them in groups. I get what you're saying. It's more that whenever somebody is logged in, you check, and then you can use that type of an account to make that SQL connection. You see what I'm saying?
Yeah.
That's insane. I'm not sure, but that's the idea. Okay. So you'll have to watch that, because I think right now when you guys created your database, you probably just used a root account with all privileges. That's one of the things in the handout that I know it's like that. And you probably, what you will do when you're configuring the system, you won't even think about it. And the problem is, if you just leave that one account, you're probably leaving that account with all the privileges. And that's not recommended. Make sense?
Yes.
Okay. All right. I do have a slide for that as well. So maybe that'll make a little bit more sense. But you just have to think about how PHP makes the SQL connection. Okay. Think about what do you need in a SQL connection? You need what? A database name. What else do you need? Like an IP. And what else do you need?
You need you need a user login.
User and login, right? Username and password. And so that account that you're using, it's going to be also have some access control associated with it that it determines the permissions that it has on the database. Got it? And so that is called the principle of least privilege, and you want to be careful about that, because if you give it all permissions just because you said, it doesn't matter, too much work. But the problem is, if somebody did succeed in a SQL injection, maybe they could delete your files. If you don't give them those permissions, it doesn't matter what injection they try, it's not going to work. So that would be the benefit of that. Okay, so most often a database account is created for the entire web application with appropriate limitations, without privileges to create and drop tables. A good compromise is to create database accounts for each class of user or class of operation. So if Joe is a regular user, he wouldn't have delete privileges for the user table. Changing user preferences as an operation type doesn't require delete privileges, right? Okay. Now this one is more relevant to the lab. As an example of a buggy login page. Remember again, the project I gave you has nothing about logins. And so you have to create a login. Remember, it's going to be a login on the server side, so it's going to be associated with a session and everything. But notice here, what's the problem? The problem is you're executing select all from users where user equal something from a form, an input. And if this is not properly validated, you're going to have a problem. Keep in mind that the way that you do these things usually is that you do a select for that user with that username and password. The password is encrypted. The password is encrypted or hashed. It's hashed in the lab even, and so you have to take that into account. But the way it works is, usually as long as you return like one record, it means that you found that account, and so you'll be authenticated. Okay? And then an ID or something is stored about that person, the privileges, etc., in some variables. So you have to be mindful of that. Okay? This is how your buggy code looks. I didn't use the exact syntax, but I did use the same logic. And so you're going to have to exploit this vulnerability to be able to bypass the login in problem 1 or problem 2, I think it was, of your lab. So what are now I'm going to give you some examples of bad inputs, right? So, or code injection. So in this case, suppose the user types in the text box. So if we look at the previous one, we have single quote, right? And there we're concatenating that with another string. And then we have the single quote over here. So really what matters in the context of the SQL query is this, right? And everything else is supposed to be data inside. If you look at this one over here, the input is, it assumes that there's already a single quote. Now the attacker plugs in a new single quote with nothing. Notice it actually is nothing. So that's not going to work because there's not going to be a match. But notice immediately after they say or 1 equal 1 dash dash. This comments out the rest. So if we go back, basically we're saying dash dash so that we can just destroy everything, right? So all that is commented out, goes away. Then the attacker closes it with a single quote. So boom, does that. So all of this now, it's also rendered. Well, that's just the inside because you have dash dash. So in between that single quote and that dash dash, the attacker wrote or 1 equal 1. So the query is now or 1 equal 1. So what does this query do? Select all from users where user something or 1 equal 1. What is 1 equal 1?
Always true.
Always true. Very good. Always true. And so even though this one did not match, this one is true. And you can see that's the idea. And so you're kind of playing around with, and this is not the only code injection. You can do more. But this is just an example of what you can try and what I want you to try in your lab assignment. And you can see what I just wrote. Basically, it's written way better than what I wrote. All right, you can see that there. The dash dash causes the rest of the lines to be ignored, so they're ignored or commented out. So you're able to bypass the login, and that's not good. Okay, so you have to input validate for this effectively. Here's another example. If they wanted to do a drop tables, you can see that one there. But this depends on the user account. So we go back to what I was saying. When you do these logins, make sure that the permissions are set right. Okay, and that's something that you have to set right in your term project because you have full control of that. They could try to add a user, right? That's a good one. Trying to add a user so that they can access the database. All right, so now approaches to prevent the SQL injection. So you never want to build these SQL commands like this, right? You never want to build them like these things, like where is it? Oops. So you never want to build them like this. It's not recommended. Okay, so that should be, so never build SQL commands yourself like that. Instead, use what are called parameterized or prepared statements. All right? There's an example of prepared statements and more description on prepared statements in your PDF. So the Seed Labs PDF, that link that I gave you. As always, I strongly recommend that you read the entire PDF document. Don't just like focus on one problem or the other. Read everything, then go back. There's going to be a lot of good explanations there. But, you know, one recommendation is to use parameterized or prepared statements in your SQL. All right. And what is a prepared statement? So a prepared statement is basically a way to separate the two channels of code and data. So here we have an example. This again, you know, it's just think of it as pseudocode. SQL command equal new SQL command. Select all from user table where user, and now you specify two specific parameters like that. Okay. These parameters in PHP, I think they're just question marks. And then below, you're always going to have this, the command.parameters.add, and that's what the thing that's going to map those variables to the inputs. But when you do it like this, this is built, you know, and that's all you have to write, really. But inside, this will make sure that something that was designated to be data will never be interpreted as code. And that's really, you know, the best approach to this kind of thing. Okay, and that's why I said that's, you know, that's why read the PDF, because in the PDF it's clear how to implement it in PHP, which basically means that that's how you're going to implement it in your lab, and that is how it is implemented in your term project. Okay. Questions about this, guys? No questions, it seems. All right, let's keep going then. All right, then there are other functions. As I said, we saw already there's some MySQL real escape string. I like that function. I think it's a good function. There's another function just called add slashes. And this one is just, you know, like you can see, you have this code injection like this. It basically provides an escaping character, the backslash. And so whenever this is shown to the MySQL engine or the SQL Server engine, they will ignore that character. Okay, so just be aware of that. Those are functions, add slashes, MySQL real escape string, and prepared statements are three things that you can use, three defenses, etc. And that's it for these slides. Let me close here. All right, and then the final set of, slides will be this one. So I probably need to share this one. All of these slides are in your Brightspace in the module. All right, so here we're just going to wrap up then SQL injections as part of your lab. You can see here, you know, this lab is about SQL injections in PHP. So just a few things here. PHP's MySQL Query. This is another, it's a function, right, in MySQL. There are variants, many variants of this can be available. And really what happens is it does not allow multiple statements. So I'll tell you this right now. There is a problem in your PDF that is kind of a trick question. And it'll ask you to kind of run 2 queries, right? But if you don't know this, you might not understand why it's not working. And what happens is that you can run SQL queries in different ways, but when you run this one, MySQL query, it does not allow multiple statements. It will only allow one. Okay, so, you know, a multiple statement would be such as this, right? So you have, this is one statement, this is another statement, this is another. So there's 3 of them, right? So it's not going to allow that. So just be aware that that's why I said you have to read the code. You have to read the code in those var ww PHP files to ensure that, you know, what is it that is running? Is it MySQL query? Because if it is, it does not allow multiple statements. And then even though this problem might be asking me to run, I'll never be able to do that. All right, but it's another security mechanism in PHP. You just have to learn it the hard way. Okay. A second ago, I talked about the MySQL real escape string, right? And basically that one is a way of validating inputs. So it really is just another escape, a more robust escaping function. So imagine here, you know, you had, again, you know, or 1 equal 1. 1 equal 1, right? So if you had that input, then you have, you know, query, right? And you have select all from users where username that and password that, right? And then you would plug in for those format strings, username and password. If you don't do the input validation, that could result in a SQL injection. However, if you run these through MySQL real escape strings, then what would happen is that gets escaped. So the input that is received by the query, you know, will not interpret this. Okay, and so therefore you took care of the attack. Okay, and then the query is just run through the MySQL query. So really, another defense here is that another defense there is that it only allows one statement. So if I asked you on an exam or something, give me the 2 defenses that are in place here against SQL injections, you would have to say, well, MySQL real escapes, not the 2, but the 2 types. You'd say, well, the MySQL real escape strings there, that's one type, and then this one, because this one only allows one statement to run and not 2. So it doesn't allow somebody to do that whole dot semicolon delete and try to insert, you know, a second statement in there. Does this make sense, guys? Are there any questions? No questions, it seems. Okay, good. All right, so database permissions. So this is the question that you guys were asking. So basically limiting the permissions on the database logon used by the web application to only what is needed may help reduce the effectiveness of any SQL injection attack that exploits any bugs in the web application. Again, I'll repeat, I've said this several times, you need to do this on the term project. I would suggest at least 2 or 3 accounts, but not 1. Okay, I'll accept just 2, you know, as long as you show me that you have 2 in there, but not just 1. For example, in SQL Server, a database login could be restricted from selecting on some of the system tables, which would limit exploits. So there's a lot that you can do with this. Here's an example of how you do that. So for instance, here, you can say in the MySQL query, deny select on sys objects or sys tables to specific login. All right, so that, you know, you go in PHP MyAdmin, you go and you in the SQL query, you run these or variants of them, and these are ways for you set the permissions. Does this make sense? Are there any questions about this part here? Database permissions?
No, not right now.
But as I said, you know, make sure you explore how to do this for your project, okay? That's really when you have to address it. All right, and CGI, that just means sometimes from PHP you could call Python scripts. As you might imagine, the problem with that is that PHP will ultimately try to run something on the terminal, right? And that might be a problem. So usually you sandbox these things, but I'm not gonna do a lab or require this for the project. All right, and that's it. So that's basically it as far as the slides. The last thing I wanna show is I'm going to go to Brightspace and we're going to open up that link for the PDF. So let me share that. Let me share. Yeah, the PDF. All right, so now, as you know, I already went over this, the lab on Thursday, I believe. You should be seeing the PDF lab right now. So we already talked about this. So remember, you are going to, on Thursday, do your demos. But if you finish early, you can continue to work on these problems. So it'll be this one and this one, right? And this was the PHP code. Pretty much everything that I've set now should be pretty obvious what's going on here. Okay, and this is the login. You're going to try to bypass that, and you're going to try to solve these problems here. So everything I'm asking you to do is until here at this point. That on Thursday we will discuss about the rest. You still have to do the whole lab, but I'm just not asking you to do it all right now. All right, the last thing I want to show you is the prepared statement. You can see this here, the countermeasure prepared statement. And this is really good because it provides a really good description of it. So I strongly recommend that you read through this, you know, all of that. And then here, you can see an actual example of a prepared statement, just like the one I just showed in the slides, but you can see this one is written in PHP. So things to notice are that, you know, here we have the question marks for the inputs, and then these question marks are just addressed here, the ID and the password. This I and S implies the data type. So ID is an integer, and password is a string. Okay, so that's why it's IS. All right, so read through this, please, the prepared statement, and you know, you can also read through the guidelines here, and that's pretty much it for today. You know, I've gone over SQL injections, and then you'll continue to work on this lab this week and next week. On Thursday, very, very important. Everyone needs to attend class, and you need to do a demo. I'll provide a grade, like a lab grade for it. I'm just gonna call it like first phase demo. It's really just, as I said, just show that you're advancing. I'm not really, you know, gonna be looking for everything, but I need to encourage you to start working hard on this, as time will run. We're gonna run out of time. All right. So at this point, I'm going to pause the video, and